Hey guys, this is Mr. Manise here again. This is going to be a pretty short video on the quiz review for how to graph radical functions. This is probably the easiest thing that we do in the entire curriculum and the easiest quiz of the year, so hopefully this is a great opportunity for you guys to make 100 on a quiz. So let's just go ahead and jump right in here. So our form for a radical when we graph it is going to be y equals a square root of x minus h plus k. And as we talked about in class, that looks very similar to vertex form of a quadratic. We'll use this for logarithms. So the a value, if there's a negative in front, that means you have an x-axis reflection is flipped over the x-axis. The a value is your stretch or your shrink. The h is your horizontal shift left and right, and your k is your vertical shift up and down. The point of origin, yes, we're going to call that the poo. The point of origin is simply going to be h comma k, just like vertex form of a quadratic. You got to remember though to flip that sign to get the coordinates. You flip the sign of the guy under the radical, leave the k value alone to get the starting point for your graph. Okay, and then we'll look at some transformations in domain and range. So let's jump right in here. For the first one, we've got y equals the cube root of x plus 4. So in the scope of this class, the only thing we're going to look at is square root and cube root. So if you guys will remember, a square root, if I have something like y equals the square root of x, that's going to, on the graph, that's going to look something like this. It's going to start and kind of go up, something like that. If you have y equals the cube root of x, then we're going to have our snake. So that's the classic snake that kind of goes up the tree. So when I see the cube root, I'm thinking this scenario right here. I'm thinking the snake. Okay. So before I plot this, I've got to figure out what are the transformations and what is the poo. So the transformations, again, I kind of read the book from left to right. Do I have a negative? Do I have a reflection? Yes or no? Do I have a stretch or shrink? That's the second thing. Do I have a horizontal shift? That's the third thing. Do I have a vertical shift? That's the fourth thing. So if I come down here and write my transformations, okay, first thing I'm looking at is, do I have a negative out front? No, so there's no reflection. Do I have an a value? No, there's none out front, so there's no stretch or shrink. And then I look to see what's inside the radical. Now, one tripping point for you guys is you got to pay attention to how far does this radical symbol go. It stops right here after the x. So some students will look at that and say, oh, I got to flip the sign of the h, that's going to be -4. But notice the radical doesn't go that far. Okay, so there's a big, huge difference between this problem where the radical stops and this problem where that radical bar is extended. Those are two completely different things. Okay, so let me just erase that. Okay, so this is like there's nothing inside the radicals. This is essentially like y equals the cube root of x minus 0. Right, and then I have the plus 4 outside. Okay, so the transformations, I don't have any horizontal shift because technically it's x minus 0. So the only transformation that I see is the 4 outside, which is our k value. That's our vertical shift. So the transformation is simply up 4 because it's a positive 4. All right, and what is my poo? My point of origin. There's nothing inside the radical, so my h value is 0. So that's going to be 0, comma, my k value, 0, comma 4. All right, so let's go ahead and plot that. 0 and then up 4. So that's where my graph is going to start. And I'm thinking to myself, this is cube root. So I'm thinking to myself, this is a snake, right? Okay, so normally, sometimes we like to try to get a very accurate depiction of the graph. Well, a lot of these radical equations, we don't have any nice numbers. Like we don't have a 3 comma 2 or a -4 comma 5 or something like that. If I were to plot, if I just look over here at number 2, if I were to put this into my calculator, I've already got this. Let me just plug in number 2 here. -0.5 square root of x minus 2, get outside the radical, plus 5, and go second table. You'll notice here that in my table, I'm not going to have a lot of nice, pretty whole numbers for a lot of these. It's going to be kind of some nasty decimals. So for this, I'm okay with you guys just drawing a rough sketch. Now, if you want to be really accurate, then yes, I would go ahead and grab a couple of points. For this one here, I could go to y equals, and I could type in what I see. I could just go math, option 4, the cube root of x, and then go second table, and I could go grab some points. I'm not gonna ask you guys to do this. If you want to, that's fine. So I've got 1 comma, let me go back, cube root of x plus 4. Yeah. Okay, second table. And I've got 0 comma 4, and I do have a nice point here, so 1 comma 5. I could plot that, and then after that it just gets kind of nasty. There's just a bunch of decimals. There's another one, 8 comma 6. I could plot that one, 8 comma 6. And then on the flip side of that, I know it would be reversed, so it would be negative 1 comma 3, and then this would be negative 8. So if I keep going here, math, option 4, cube root of x plus 4, second table, and I've got negative 1 comma 3, and then of course I have the, just to show you on the calculator, negative 8, negative 8, negative 2. And then this would be our snake. Again, I'm not going to force you guys to do this on the quiz or the test. You can just simply go punch it into your calculator, punch that in, and go ahead and graph it. And let's just see a general sketch of what it looks like. And just to make sure, now you got to make sure that you've got your correct shrink or your stretch. So if there's a huge stretch, but you draw a straight line to make it look like a shrink, then I'll have to take off some points. So you can either just plot it on your calculator and make sure your sketch matches this sketch, or you can go grab a couple of points and make sure you have an accurate graph. Okay, so what is the domain? What is the domain of this? I have x values everywhere. So a cube root, I can always take the cube root of a number, whether it's positive, a decimal, negative. I can take the cube root of any number. So I will have x values everywhere. I will have y values everywhere, because this thing goes on forever. All right, so my domain and range for any square root or cube root will always be negative infinity to infinity for both of those. Okay, number 2. I'm just going to write T for transformations so I can get through this video pretty quickly. Do I see a negative? Yes, I do. So that is an x-axis reflection. Okay, you've got to put x-axis reflection. You can't just write reflection, because I don't know if you know whether or not it's a y-axis or an x-axis reflection. Okay, what else do I see? Do I have a shrink or stretch? Yes, I do. Now remember, the negative has nothing to do with the shrink or the stretch. Okay, so if you have something like y equals negative 2 square root of blah blah blah, some students will look at that negative 2 and say, oh, it's less than 1, that means it's a shrink. No, we're only looking at the absolute value of that a. The absolute value of this is 1/2. That's less than 1. So if you have a fraction 3/4, 0.2, 0.68, all of those would be shrinks. Okay, so I have a shrink, and you got to tell me by how much. I've got a shrink by 1/2. Okay, I've got a horizontal shift. You got to flip that. Remember, it seems like it would go left 2 because it's negative 2, but you got to flip it because it's x minus h. So this is actually shifted to the right. So this is right 2, and then we've got up 5. Okay, the poo. All right, flip that sign. It's going to be 2 comma 5. Let me zoom out here a little bit so y'all can see everything. Okay. All right, domain. Let's go ahead. I can't do domain and range until I plot it. So once again, for sake of time, I'm going to do this maybe one more time, and then I won't do this for the rest of these. I trust that you guys can punch these in your calculator. So negative 0.5. Oops. Negative 0.5, second square root of x minus 2. Now I got to press the over button. Make sure you press this to get outside the radical. Okay, plus 5. If you don't get outside the radical, if you leave that on the inside, let me do that again. Negative 0.5 second square root of x minus 2 plus 5. You can't do that, because notice the 5 is still inside the radical, so make sure you don't make that mistake. You got to press the over button, get outside the radical, and then press plus 5. Okay. So if we want to graph that, see what it looks like. All right, so there's our poo sitting at 2 comma 5. So if I plot that, 2 comma 5. All right, so normally this is the square root. So normally I'm thinking my graph does that. Okay, but there's a reflection. So I know it's reflected, and then it's got a shrink of 1/2. So this will be a normal reflection, but it's a shrink, so it's going to be a little bit straighter, a little bit more narrow. Okay, and you can kind of confirm that with the graph here. Okay, so I'm just looking here. Looks like it's getting down around 3 or so, where it starts to flatten out. So I'll just kind of drop down. See, it starts to flatten out around 3 or so, something like that. Right. Number 3, transformations. No reflection, no shrink. All I have is left 1. That's it. My poo, flip that sign, -1. And then what's my k value? There's no k out here, so that's like +0. So my k is 0. So my point of origin is -1 comma 0. It's the square root, so I'm already thinking that it looks something like that. There's no reflection, so if we plot this, actually, again, I'll let you guys plot this, just so this is a short video. It's just our normal parent function. It's just translated 1 to the left. Okay, so my graph's going to look something like that. Okay, now domain and range. Now domain are all my x values. When you have square roots, oh, I'm sorry, I forgot to do this back up here. Let's go back up to this one, number 2. I forgot to do domain and range. Now when you have a square root, you will have certain domain and ranges that the values won't go past. So the domain are all of my x values. So where do I have x values? I don't have any x values until I hit this guy right here. So if you notice, I don't have any x values until I hit 2. So my domain will be 2, and I will continue to have x values from 2 all the way until I hit infinity. So 2 to infinity. Do I include 2? Yes, I am physically touching that point because that is part of my point of origin. So I do need to put a bracket on the 2. All right, for the range, I'm always sweeping from bottom to top. Okay, where do I have y values? I know this flattens out, but technically it will go all the way down here. So I do have y values from -infinity, which I can't touch, and I will continue to have y values all the way until I hit a y of that guy, which is 5. Okay, so -infinity until 5. I am touching that point, and so I do put brackets on it. But what do you notice about the 2 and the 5? These are simply our coordinates of the poo. Okay, so you got to remember that your domain, your x values, are based on the x coordinate of the poo, or the h value. So your domain is based on the h value, and your k value, your y values, are based on the k. Okay, so domain is based on the h, the range is based on the k values. All right, so let's go back down here to number 3. Okay, where do I have x values? Really, I don't even need to look at the graph. Okay, I know that the graph is going this way, so the domain, it starts at the poo. Okay, so I'm starting at the poo, and I'll have x values forever. So I start at -1, I'll continue to have x values forever. The range, I don't have any y values down here. I got nothing. This is just a big void. I don't have any y values until I hit a y of this guy, which is actually just sitting there at 0. Again, the k value of my poo, or the y coordinate of my poo. Alright, so the range will be I have nothing. I start at 0, and then I will continue to have y values forever. So 0 to infinity. Okay, number 4. Transformations. What do you see? No reflection, no shrink. Now this one, again, this is kind of like number 1 up here. I don't have anything inside the radical because the radical bar stops right there. Okay, so I don't have any horizontal shift. This is my k value. That's just -4, so that's just down 4. Zoom in a little bit. Okay, so down 4. What is my poo? My h is 0, so that's going to be 0 comma -4 for my poo. So that's going to be 0 down 4. That's about right there. Now this is a square root, so again I'm thinking that shape. I don't have any reflection, I don't have any shrink, so this is just our normal radical graph. Okay, domain, where do I have x values? I have nothing here. I have no x values until I hit that guy right there, which is the y-axis. So my x values start at 0, the h coordinate of the poo, and they will go on forever. My range, I don't have any y values. I got nothing down here until I hit a y of that guy, which is the h coordinate of my poo. So my range is -4, and I will continue to have y values forever, -4 to infinity. All right, making good time. Let's flip on over. Okay, number 5. Now, number 5 is a little bit tricky. Okay, some of you guys might look at this and say, "Oh, I've got an x-axis reflection," and actually, let me zoom in a little bit on this one just to make sure. Some of y'all may look at that and say, "I've got an x-axis reflection. I've got a stretch of 2," but notice that guy right there. That is called a plus symbol. Okay, so normally our equation, looks something like this: y equals -2 square root of x minus 1 plus 3. Something like that. And notice here, that's multiplication. The -2 is being multiplied times this. That is a plus symbol. So they have thrown you a curveball. This -2, that is actually your k value. They just put it in the front. So if I switch this over here, move it over to the back end, then this becomes y equals the square root of x minus 2. Okay? All they did was they took the -2 and they put it in front, plus the square root of x. Okay? Now we're in a position that we're used to seeing. We got it in the form we're used to seeing. Standard form from our radical. Okay, so let's go ahead and do our transformations. The only thing that I see is a k value of -2, so that's down 2. My poo, I got nothing in the radical, so that's going to be 0, comma, my k value, 0, comma, -2. Alright, so let's go ahead and plot that. 0, -2 is right there. I don't have any reflection, I don't have any stretch or shrink, so this is going to be our normal radical graph. It looks something like that. My domain starts at 0 and goes on to infinity. Bracket. You will always have brackets on the h and k values of the poo because we're literally touching this coordinate point. I'm always touching that value. I'm always touching that value. So 0 to infinity, and then my y values start at the k value and go up. So -2 to infinity. Okay, number 6. Cube root, so I'm thinking my normal snake, right? So my transformations, no reflection, I see a shrink by 1/2, and then there's nothing else. That's literally all that is. Okay, so my poo is 0, comma 0. This is like x minus 0 plus 0. Okay, so my poo is the origin. All right, domain and range. So our normal snake, when we plotted this in class, and I actually just plotted this on number 1, I think it was like 8, comma 2, or actually the other one, number 1, we didn't have any stretch or shrink. But in class, if you remember when we plotted this, I think it was like 8, comma 2 and -8, comma -2. I'll do this one more time just to refresh your memory on this. So our normal math cube root of x second table, you can see here that we've got the points 0, 0, 1, 1, and then we had 8, comma 2. Okay, however, there's a 1/2 in front. So we're cutting all that in half. So actually it's 8, comma 1. And then I've got the origin, and then we have -8, -1. So remember, when I have a shrink, my graph's going to look a little bit more narrow, a little bit straight or something like that. So we have a graph that looks something like this. Pretty flat and pretty narrow with that shrink value of 1/2. Domain of range is always going to be -infinity to infinity for a cube root. Okay, number 7. Transformation, I see a negative, so that's going to be an x-axis reflection. What else do you see? I see a 3, so that's going to be a stretch by 3. Again, remember the negative has no effect on the stretch or the shrink. I don't have any horizontal shift and no vertical shift. My poo is 0, 0. Okay, so this is my origin. All right, so normally, this is a square root, so I'm thinking that shape. Okay, but it's a reflection, so I'm thinking that shape, and then it's a stretch, so it's going to be a lot broader and wider. Okay, if you want to plot this just to kind of get an idea of what it looks like, let's type in -3 math. Oops, sorry, this is square root. Second square root of x, and we can kind of get a general shape here. So it's going to be pretty wide and pretty pretty broad down here. Okay, domain and range. Domain, everything's going to be based on 0. Domain is 0 to infinity. In the range, I have y values. Remember, you're always sweeping from bottom to top. I have y values from negative infinity up to that y coordinate of 0. And of course, both the zeros have the brackets on them. Okay, number 8. All right, transformation. What do you see? I see a stretch of 2. I see a horizontal shift. Flip that sign is going to be right 4. If you can't remember flipping the sign, oh man, is it left 4, is it right 4? Just graph it, and you'll be able to see, is my graph shifted to the right? Is it shifted to the left? That's a way to make sure you don't make a mistake on that. All right, and there's no horizontal, or there's no vertical translation. Okay, so my poo, flip that sign, that's going to be 4 comma, my k value is 0, that's like plus 0, so 4 comma 0, so that's going to be right 4. Okay, this is a cube root, so I'm thinking the snake. I'm thinking the snake goes up the tree. There's no x-axis reflection, but it's a stretch of 2, so it's going to be a little bit wider, with the snake. Okay, and again, you can graph that on your calculator to get a rough sketch there. All right, home stretch, last 2 here. This is cube root number 9. So again, I'm thinking snake goes up the tree. Okay, transformations. I see a negative, so that's an x-axis reflection. Okay, the poo, flip that sign, leave that alone. Negative 1 comma 0. All right, so there's my point of origin. Okay, so I've got a reflection. So the normal snake does that. So the backward snake comes down the tree, right? That's a backward snake. And then I have a shrink of 1/2. So not only is it going to come down the tree, it's going to be really, really skinny. Okay, so it's going to look something like this. Pretty skinny, pretty flat. Again, you can go second table, pick a couple of points, try to plot those. Domain and range for cube roots is always negative infinity to infinity. And number 10, this is square root, so I'm thinking that shape. No reflection. I do have a stretch of 2, so stretch by 2. All right, do I have a horizontal shift? I do not, because that radical bar cuts off at the x. Okay, so the negative 4 is actually my k value, so that's just down 4. My poo is there's no h value, so that's 0 comma my k value, 0 comma negative 4, which is down here again. All right, so normally this is my normal graph, but there's a stretch of 2, so again it's going to be wider and broader. So it's going to look something like this. Okay, my domain, I have my x value start at 0 and go on forever. So 0 to infinity. And my range, I have y values. I don't have anything down here. I don't have any y's until I hit that y coordinate, the k coordinate of my poo. So the range will start at negative 4, and I will continue to have y values forever. So negative 4 to infinity. All right, that's it, guys. Very, very easy concept. A nice, short, sweet video. This is your chance to make a 100 on a quiz, so make sure that you're taking your time on the quiz. Make sure you've got brackets where it's supposed to be. Make sure you plot and graph the stuff on your graphing calculator to make sure that you didn't forget to flip the x-axis reflection or whatever. So hope you guys enjoyed that. Good luck on the quiz, and we will see you on the next video.